So question one was a proportional question, and the idea behind proportion equations is thusly. If two things are proportional, you're looking for certain keywords. For example, if I tell you some variable, say y, is directly proportional or varies directly, but the word directly is the key word that you're looking for, to another variable, say x, the setup is y equals kx. Now, if the keyword is inversely, so those are the keywords you're looking for, either direct or inversely. This is the setup here, y equals k over x. And the idea is that if you have a direct proportion, notice how the variables are sort of like on the same level in the equation. There's no fractions, they're both in the numerator for directly proportional. But for inversely proportional, notice how the y is just a regular y, yet the x is in the denominator. And that's sort of like the idea there. Directly proportional quantities, they're on the same level of an equation. Inversely proportional quantities, they're on opposite levels of an equation. But regardless if it's a directly proportional or inversely proportional, notice that you always start the same way. Letter variable equals k. You always have a constant proportionality k. So if you're reading this question, it says t is jointly proportional. Now, the word jointly, it just means you have more than one, but I immediately know that this is a proportional question. So I'm going to start off with the same way you start off every proportional equation. Variable equals k. Now, all you have to do is figure out what is he directly or jointly proportional to. Well, clearly it says to x and y. But it also says inversely proportional to r. So the idea is that anything that's directly proportional will be on the top level, and anything that's inversely proportional will be in the bottom level, in the denominator. So clearly xy is on top, because that's directly proportional, and r is in the bottom. Next, they give you numerical information. This usually means plug stuff in and solve for whatever variable's left over. So they tell me that the x is, well, let's start from left to right. So t, they tell me t is 40. They don't give me any information about k. They tell me x is 4, y is 2, and r is 14. Lo and behold, it gives you a regular equation to solve. So go ahead and solve for k. So I'm going to multiply both sides by 14. That gives me 560 equals 8k, and then divide both sides by 8 gives you k equals 70. So then all you have to do is write what I call the complete equation. The complete equation is the proportionality equation that you set up with everything staying as variables except for the k that you solve for. So my final answer would have been t equals 70 xy over r. So that's how you do proportional equations. Number 2 was a properties of exponents question, and again, these properties here, you sort of have to know them by now. If you don't, make it a concerted effort to put them to memory. So we have the product property on top here that says when you multiply like bases, you add the exponents. The quotient property, when you divide like bases, you subtract the exponents. Power property, it says if you have stacked exponents, an exponent raised to an exponent, you multiply them. Negative exponent property says if any base has a negative exponent, you reciprocate the base. In other words, the first bit basically says if you have a term in the numerator that has a negative exponent, you just go ahead and bring that base to the denominator. Or if the guy is already in the denominator has a negative exponent, you just bring him up to the numerator. And then lastly, almost anything to the 0 power is 1. So when it comes to simplification problems, there are lots of different avenues you can take. The way I'm going to present it is not, there's nothing special about it. It's just the way that I notice things. So the first thing I'm going to do is probably distribute this exponent of -4 to all the inner exponents here. So this gives me x to the -8, y to the positive 12, z to the positive 12, over x to the -16, y to the -8, z to the 24. Next, what I'm going to do is apply the quotient property. And again, the quotient property only works for like bases. So we're going to do it for the x's separately, the y's separately, and then the z's separately. So let's go ahead and do the x's here. So the quotient property says you do the numerator minus the denominator, so that's what we'll go ahead and do. So this gives me x to the negative 8 minus 16, negative 8 minus a negative 16. Moving on to the y's, that's 12 minus a negative 8. Moving into the z's, just the top exponent minus the bottom exponent. And that gives us x to the 8, y to the 20, z to the negative 12. And then the negative exponent rule says any base that has a negative exponent, you flip them. So the x stays put and the y stay put because they had positive exponents, but the z exponent goes down. Number 3, when it comes to writing equations, linear equations, it doesn't matter if you're in pre-calculus, algebra 2, algebra 1, or calculus and beyond, you're doing the same thing over and over and over again. To write a linear equation, you absolutely need a slope and a point. Fortunately, hopefully we can see that they give us both pieces of information. We have our point and we have our slope, so we are good to go. You can use y equals mx plus b, or you can use y minus y sub 1 equals m times x minus x sub 1. I like to use this format, and that's what I'm going to show in my solution. That's what I did in my notes. But if you want to use y equals mx plus b, you should get the same answer in the end. So the idea is that this is your slope, and these is where you put substitute in your points. The regular x and the regular y stay as variables. So let's go ahead and do that. We have y minus, our y value of our point is negative 2, equals m, our slope is negative 7 halves, times x minus, our x of our point is negative 6. Go ahead and take care of the double negatives. Y plus 2 equals negative 7 halves, x plus 6. And then go ahead and write your final answer in slope-intercept form, basically solving for y. So we're going to go ahead and distribute here. So that's negative 7 halves x. So negative 7 halves times 6 is going to be negative 21. And then we'll go ahead and subtract 2 from both sides, giving us negative 7 halves x minus 23. Number 4, to divide complex numbers, we have to remember that by definition, I is the square root of negative 1. So when you have a 2 plus 3i in the denominator, that's the same thing as having a radical in the denominator. And what do we do with radicals in the denominator? We rationalize. So the technique to rationalize a binomial is to multiply by the conjugate. Not surprisingly, that's the technique we're going to use. So to, quote, divide these two complex numbers, I'm just going to multiply everything by the conjugate of the denominator, which would be 2 minus 3i. 2 minus 3i. And then you just go ahead and multiply, right? Just multiply it all out. So what would this give us? This would give us a 6. This would give you a minus 9i. This would give you a minus 2i. I'm running out of colors here. Let's go back to black. And this will give you a positive 3i squared. Now in the denominator, I could FOIL that out, but the reason why we multiply by two conjugates is that the product of two conjugates is always the difference of the squares of the terms. So in our case, 2 plus 3i times 2 minus 3i, I don't have to FOIL. I know it's going to be this guy squared minus that guy squared. So that should be 2 squared minus 3i squared, which is 4 minus 9i squared. So that's is how I multiply up the denominator. I'm just going to exploit the pattern. So then all we have to do is combine like terms, simplify, yada yada yada. So that's 6 minus 11i plus 3i squared over 4 minus 9i squared. Now we have to recall that any expression with i's in it, if you have an exponent, you can always simplify them. You have to remember that I squared is negative 1, so we can go ahead and do that substitution. Everywhere you see an I squared, we change that to a negative 1. when you multiply by -1, it just flips the sign. So this becomes 6 minus 11i. Instead of a plus 3i squared, it becomes a minus 3. And then denominator 4, instead of a minus 9i squared, it becomes a plus 9. And then it gives us a grand answer of 3 minus 11i over 13. Now technically, standard form of complex numbers should not be one giant fraction. It should be two separate pieces. So what we're going to do is split the fraction, giving each term its own denominator of 13. Number 5 was just a straightforward word problem. I gave you sort of a hint there. Use similar triangles. So a man is walking away from a lamppost with a light source 8 meters above the ground, indicated in the picture here. The man is 2 meters tall, indicated in this picture here. How long is the man's shadow when he is 9 meters from the lamppost? So they gave us the 9 meters here, and they're asking for a shadow. Now, it said use similar triangles as an example, and hopefully we can see that there are two triangles in this picture. You have this smaller triangle here, and then you have this bigger, well, that's a bad color. You have this bigger triangle here. So I'm going to just like redraw outside of the picture. So we have the big triangle, and we have the small triangle. Now, I'm just pulling the information from the picture. In the small triangle, that is x, and this is 2. And in the big triangle, this is 8. Now, we have the common mistake I saw was people did not label this side correctly. This length here in the picture is this length here, and clearly it's not just the 9, but it's the 9 with the x, specifically 9 plus x. So now we can set up our proportion, right? Let's do, I don't know, bottom over top. So 9 plus x, that's the bottom, over 8, that's the top, should equal, moving on to this triangle, the bottom x over the top 2. And then lots of different ways to solve proportional problems. I think the easiest way is to cross multiply. So if you cross multiply, you get 8x equals 18 plus 2x, and then just becomes a simple linear equation. Subtract the 2x over, 6x equals 18. Divide out the 6, get x equals 3. So his shadow is 3 meters long. Number 6 is a straightforward linear inequality. Hopefully it wasn't too challenging, but notice the instruction wanted interval notation. By now, I expect you to know what interval notation is. If you do not know what interval notation is, well, you need to see me sometime outside of class, and we need to get you caught up. But this is just straightforward solving for x. So the first thing I would do is subtract 13. And then go ahead and divide out the 3. X is less than -2. Visually, x is less than -2 looks something like this. Notice it's an open circle because the inequality does not have the line underneath it. It's not or equals to. In interval notation, we can see that it goes to the left forever to -infinity, comma, and then it stops right at -2. Infinities are always open, and because -2 is open, we use a parentheses. That is the solution to this inequality. That's a solution set, rather. Number 7 is just a straight up quadratic equations. Notice it says if your answer is complex, put it in that format. So to solve a quadratic, you want 0 on one side, so we'll go ahead and subtract 2x from both sides. I notice all the numbers are divisible by 2, so let's make life easier on ourselves and just divide everything by 2. So this is a nice little handy. If you notice, you can make all the numbers smaller. Go ahead and do it. It makes life easier. So it gives me x squared minus x plus 2 equals 0. And normally I would love to solve this by factoring, but gosh darn it, it is not factorable. I personally, Mr. Vo, would complete the square, but I know some of you guys don't like completing the square, especially if it involves fractions, so we'll just do the good old-fashioned quadratic formula. So the quadratic formula says, well, in this case, hopefully we can see that a is 1, b is -1, and c is 2. Quadratic formula says your solution to any quadratic should be opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'll just substitute everything in. Negative b is negative 1, plus or minus the square root of negative 1 squared, minus 4 times a is 1, times c is 2, all over 2 times 1. Notice I use parentheses when I substitute. So that gives you a 1 plus or minus the square root. All the stuff inside here, I'm just going to do mental math, or heck, just use a calculator if you want. That gives you a negative 7 over 2. Now the idea is that anytime you take a square root of a negative number, all you have to do is pull out an imaginary unit I and make the radical positive. So this is the same thing as 1 plus or minus I radical 7 all over 2. There we go. But again, when it comes to complex numbers, we don't want one giant fraction. We want to sort of split it apart. So all I'm going to do is split apart this fraction. So give every single piece its own denominator of 2. So 1/2 plus or minus rad 7 over 2 I. Right. A lot of people gave me this as an answer, and I gave you full credit for it. But technically, this is in standard form. Number 8 should have been a gimme question. We know that all linear equations can be written as y equals mx plus b, where b is your y-intercept, where m is your slope. G, look, they give you a slope. They give you y-intercept. You're done. So the answer is y equals 7x minus 4. Right, a gimme problem. Number 9 is a proportional problem, and just remember that the key words to look for is directly proportional, inversely proportional. So if you have something that is directly, they can use proportional, they can use varies, but the key phrase there is directly. The way you set it up is put those two variables on the same level of the equation. If it uses the words inversely, because you say variation, proportion, doesn't matter, but the key word is inversely. The idea is to put that variable on the denominator, put them on opposite sides of the equation. But regardless if you have direct or inversely, notice you always have variable equals k. So that's how you always set up every single proportional equation, variable equals k. So let's read this problem. Hooke's law states that the force needed to keep a spring stretched x units beyond its natural length is directly proportional to x. So the players are force directly proportional to x. It doesn't give us a variable for force, so let's just make up our own variable. I think F is a very natural for force. So it says F is directly proportional, so any proportion problem, directly or inversely, you always start with variable equals k. And since it's directly proportional to x, directly, I'm going to put the x on the same level. Then they give you numerical information, numbers. That typically means you're going to plug stuff in and solve for k. Well, what numbers do they have? So that gives us a spring, let's say the natural length of 10, force of 40, stretched to a length of 18. Now this confused a lot of kids because x is distance. They give me two distances. Well, I hate to say it, but you actually had to read for once. I know, who would have thought you needed to read? It says that x is the units beyond its natural length. Well, it says its natural length is 10. It got stretched to 18. X is the number of units beyond the natural, so if you start at 10 and stretch to 18, hopefully everyone can see that x is going to be 8. So in this case, you just plug everything in. They gave you F is 40 newtons, x is actually 8 centimeters, just plug everything in. 40 equals k times 8, divide both sides by 8, you get k equals 5. So there's our complete equation, force equals 5x. So then we can actually answer the question by using the secondary piece of information. It says, what is the force necessary to keep the spring stretched to a length of 17 centimeters? Remember, the natural is 10, so if we stretch it to 17, x is actually 7. So just plug it in. F equals 5 times 7, so F equals 35 newtons. Number 10 is a nonlinear inequality, specifically a rational inequality. So the idea is that you want 0 on one side and everything clustered together as one fraction, which in this case is done. We do have one giant fraction. So next, what we're going to do is find our critical values by separately setting the top equal to 0 and then the bottom equals to 0. Right? So setting the top equal to 0, hopefully that's not too hard, that's x equals 3. Setting the bottom equal to 0, again not too hard, x equals negative 2. We put these critical values on our number line. This is called creating a sign diagram, by the way. This is the idea that any critical values from the denominator is always going to be an open circle. Critical values from the numerator will depend on the inequality. Because the inequality is or equals to, it has that little line underneath it, this will be closed. So then all you have to do is pick numbers in each region. What do you mean by each region? We have a region to the left here, we have a region in the middle here, and we have a region on the right here. So all you got to do is just pick a number in each region to test into the inequality. So I don't know, just picking numbers by random here. Let's go ahead and, let's pick negative 3. Let's pick 0. Let's pick 4. And all you do is literally just plug into the inequality. So testing x equals negative 3. I get negative 3 minus 3 over negative 3 plus 2. I don't really care what the answer is. All I have to care about if it's positive or negative. So on top, negative 3 minus 3 is negative. And in the denominator, negative 3 plus 2 is negative. And negative over negative is a positive. Right. So we're going to test the other numbers in the identical way. So for the other two numbers, I'm not going to show my work. I'm just sort of going to go fast forward, just tell you what the answer is. But I hope you understand what I'm doing. All I'm doing is taking these test numbers, and you're going to plug it into the original inequality. So if you do the same thing with x equals 0, you're going to get a negative. And if you do the same thing with x equals 4, you're going to get a positive. So I'm going to put those symbols up here. Next, you look at the inequality. It says greater than or equal to 0. That means positive numbers. If it said less than 0, you want negative numbers. So on my number line, I'm only going to shade the regions, and I'm going to look at these things I put on here. You only look at these regions. I'm going to shade the regions that are positive, and I hope people can see that that means it's this part of the number line and this part of the number line. And then all we have to do is write that as a, integral notation. So we have two regions. Let's work on the left region here. So we can see that shades forever to the left. That's negative infinity. And it goes all the way to negative 2. They're both open. I do have another region here, so I need to tack on a union. And then this region starts at 3, but it's closed, so I use a square bracket. And it goes forever to infinity. That is the solution set for number 10. Number 11 is a compound inequality, specifically an and compound inequality. So all you got to do is just focus on the middle here, because that's where the x is, and then just do math. The only thing that's different is you're going to have to balance all 3 sides instead of 2. So this one I will actually write out my work so you guys get an idea what I mean by balance all 3 sides. So the first thing I want to do is subtract the 5, but when I subtract the 5, I'm going to do it to all 3 sides. That gives me negative 6 is less than 2x, which is less than or equal to 6. And then just go ahead and divide out the 2. So you get negative 3 less than x, which is less than or equal to 3. If you wanted to visualize this on a number line, notice how for the negative 3, there's no line underneath the inequality. So this will be open. See, for the 3, there is a line underneath the inequality, so he will be closed. And I'm going to shade, because x is in between those two, the shading is, well, everything in between. And to write that in integral notation, very simple, because you can just see it. You start at negative 3, comma, you end at 3. At negative 3, he is open. At 3, he is closed. Number 12 asks you to rationalize the denominator. Notice that we have a square root in the denominator, but he's a part of a binomial. So the idea to rationalize binomials is to multiply by the conjugate. So the technique is to multiply by the conjugate of the denominator. But of course, what you do to the denominator, you must do to the numerator. And then all you gotta do is just multiply it all out. It's as simple as that. So that's 10 plus 2 rad 11 over, you could FOIL out the denominator, but the reason why we use conjugates is because we should know that the product of two conjugates is the difference of the perfect squares. So if I have 5 minus rad 11 times 5 plus rad 11, I don't need to FOIL because I know it'll be this guy squared minus that guy squared. So we should know that it's going to be 5 squared minus the square root 11 squared. And of course 5 squared is 25 minus the square root of 11 squared is just a regular 11. And then all I got to do is to simplify, do math. 10 plus 2 rad 11 over 14. Now when it comes to simplifying giant fractions like this, you have to look at all of the coefficients or constants, all of the outside numbers, and ask yourself, can I reduce all three of them at the same time? If the answer is yes, you go ahead and do that. If the answer is no, not all of them at the same time, you don't. In this case, 10, 2, and 14, we can simply divide out a 2 from each of them, giving us our most simplified answer of 5 plus radical 11 over 7. Number 13, there really wasn't no trick to this. It was either you knew it or you didn't know it. What property is being exhibited here? Anytime I'm trying to analyze properties, they give me parentheses, I sort of look at the grouping of the parentheses. Notice the parentheses stay the same. It's 10 plus y in each of them. So the grouping or the associations did not change, so it's not the associative property. And notice we basically have two factors here, the 9x's and the parentheses 10 plus y, and they flip-flopped. We reordered them, we moved them, and when you move terms, it's the commutative property. Right, so there really was no trick to this. You either knew it or you didn't know it. Number 14 was just straight up following instructions. Just do what it tells you to do and simplify. So I hope this was not too confusing. So the first thing I notice is stuff in front of parentheses that tells you to distribute. So I'm going to distribute the 4 here. That gives you 4x squared minus 16x plus 4. And then we're going to distribute the minus 3. You have to distribute that negative as well. So it's a negative 3x squared plus 6x minus 3. And then all you got to do is combine like terms. We have x squares like terms. We have x's, regular x's like terms. Ooh, that's a bad color. And then we have the constants as like terms. So then we have our answer of x squared minus 10x's plus 1. Right. All you got to do is just combine them, add them up. Number 15 was a proportional problem. And again, just to refresh our memories, the key words to look for is directly. If they say directly proportional, varies directly, it doesn't matter, it's the word directly that we're looking for. The way you set it up is variable equals k always, and if it's directly, you just slap on the variable in the same level. If they use the word inversely proportional, varies inversely, doesn't matter. The way you set it up is variable equals k, and since it's inversely, you put the other variable in the bottom. So no matter what, you always start with variable equals k, but if it's directly proportional, you put the other variable in the top. If it's inversely, you put the other variable in the denominator. So let's read the story. The pressure P of a sample gas is directly proportional. So already they give me variable directly proportional. So it can immediately start with variable equals k. Any proportion problem, you can start off with variable equals k. Well, what is it directly proportional to? Temperature T and inversely proportional. So that's a different proportionality. So I'm going to stop here. Because it's directly proportional, I'm going to put the T on top. Now they're giving me a new proportionality, so let's switch to a different color. Inversely proportional. What is he inversely proportional to? The volume. Well, because it's inversely, you're going to put on the bottom. There you go. They give you a whole bunch of numerical information, so that usually means you're going to plug stuff in to solve for K. So what information do they give you is 120 liters of gas, 34 kilopascals, and 200 kelvins. My screen flickered there. Hopefully the recording didn't stop. Okay, good. Right. If you did not know, liters of gas is a volume, kilopascals, they says it's a pressure, and 200 kelvins, they tell you it is temperature. So just plug everything in. So pressure is 34 K, temperature is 200, and volume they told you was 120. And then it's just a regular equation to solve for K. So we're going to multiply both sides by 120 to get rid of the denominator. So 120 times 34 is 4080. And then divide both sides by 200, you get 20.4. Once you solve for K, you can create what I call a complete equation. Just put it back into the proportional equations you're set up with everything as variables except for K. So there's our complete equation. Now we can actually use the second piece of information, all this stuff here. Oops, no, that was the hint. All this stuff here to answer the actual question. So notice they say the temperature's increased to 600 kelvin, so that's clearly temperature. Volume's decreased to 40 liters, that's clearly volume. What is the pressure? So that's asking for P. So just plug all the stuff in. P equals 20.4. They said the temperature was 600 kelvins. They said the volume was 40 liters. There you go. You're done. Just pop that guy into your calculator and figure it out. So 20.4 times 600 divided by 40 is 306 kilopascals, which was choice B. So there you go. Right. Number 16 was an absolute value inequality problem. And there really is no secret to this. As we discussed in class, there are particular setups for these types of problems. If you want to know why the setup is the way it is, please ask me outside of class, but we did discuss it during the lesson. So in this case, we have an absolute value of stuff is less than some number. I'll use a letter here, say C. So the way you set these problems up is all of these problems are always that negative of that number C less than the stuff inside without the absolute value less than the original number C. So in this example, if I have absolute value of 5x is less than 15, the way I would set it up is say negative 15 is less than 5x, that's the stuff on the inside, which is less than the regular 15. And then you just solve it like normal. Divide everything by 5 to get the x by itself, and you get negative 3 less than x less than 3. It said use interval notation, so if I were to visualize this answer, my special numbers are 3. Both the inequalities do not have a line underneath it, so they will remain open, and x is between them. So this would be the shading there. So the interval notation would be starting at negative 3 and ending at 3, and they're both open. Number 17 is a proportional statement. So again, just to refresh our memories, the key words to look for is directly and inversely. They could say proportional, they could say variation, but if they say directly, the way you set it up is the first variable equals k, the second variable. If they use the word inversely anywhere, the way you set it up is first variable equals k, but the second variable is in the denominator. So that's the idea. Notice every proportional equation starts off the same way. First variable equals k, but where you put that second variable will depend on the key phrase there. Directly proportional, you put the second variable in the numerator on top, and if it's inversely, you put the second variable in the denominator. So let's read this. It says S is inversely proportional. Well, the moment I know it's a proportion problem, you do first variable equals k, and what is it inversely proportional to? The square root of t. So because it's inversely, I'm going to put the square root of t in the denominator. They give me a whole bunch of numbers, which usually means plug it in to solve for k. So they say s is 140, k over the square root, and they say t is 36. And then, what do you know? This gives you an equation to solve. So I can go ahead and do that square root. That's 6, and then multiply both sides by 6 gives us 840 equals k. So then we have we can create what I call the complete equation, which is to rewrite your proportional statement with everything as variables except for k. You actually want to plug in that number. So that is the proportional equation for that statement. Number 18, it's just multiplying complex numbers. The idea is you just multiply the same way you do with polynomials. So see how it's telling you to multiply those guys? So just do regular repeated distribution, or FOIL as some of you guys like to call it. So we have what? That is 7 times 3 is 21. 7 times a plus 3i is a positive 21i. Then we have a negative I times 3 is a minus 3i. And then we have a minus I times a 3i is a minus 3i squared. Combine like terms, and you really only have one pair of like terms, which are these i's here. So you get 21 plus, what's that, 18i minus 3i squared. Now, when it comes to working with imaginary numbers, the idea is if you see an exponent on an I, you can always simplify him. So we have to remember that I squared is the same thing as negative 1. So this guy here, you can substitute in a negative 1. Now we should know that when you multiply anything by negative 1, all that happens is the sign changes. So when I do that substitution, instead of a minus, I'm going to put a plus. So then this becomes 21 plus 18i plus 3, and then go ahead and combine the regular numbers to give you 24 plus 18i. Number 19, again, it's the same thing, just do stuff with complex numbers. In this case, they're asking you to add these two numbers. So to add complex numbers, you just literally combine like terms. 2 minus 4i plus 4 plus 3i. The reason why they put them in parentheses is because technically these guys together form one number. But when it comes to adding and subtracting, you can just treat them as separate terms. So since there's nothing multiplying these parentheses on the outside, you can sort of just drop them. And the idea is to combine like terms. So here are my regular numbers. Here are my i's. And when we put them together, 2 plus positive 4 is a 6. Negative 4i with a positive 3i is a minus 1i. There you go. Number 20, solving linear inequalities. It's just like solving a regular equation. Just get x by itself. The only extra thing we have to do is make sure our final answer is in interval notation. So the first thing I'm going to do is just go ahead and distribute this 3. I'm going to break down the parentheses. So that's 15x minus 6, less than or equal to 12x plus 27. And I'm going to go ahead and get all the variables on one side and the regular numbers on the other. So I'm going to subtract this 12x over, while at the same time, I'm going to add the 6 over. So this gives us 3x less than or equal to, what's that, 33? And then divide both sides by 3 gives you x is less than or equal to 11. If you were to visualize this in the number line, here's 11 there. Notice the inequality is or equals to. It has that little line underneath it, so that tells you it's going to be a solid circle. And then I want numbers that are less than that, and numbers get smaller to the left. So that would be my shading here. Notice we'd be shading forever to the left. So forever to the left would be negative infinity, comma, and we keep going to the right until we stop at 11. Infinities are always open, and since the 11 is closed, we're going to use a square bracket. That is the interval notation to the solution set of this problem. Number 21 is a nonlinear inequality. So the idea is you want to get 0 on one side, which they did it for you. And once you have 0 on one side, you're going to pretend that it's an equation, because we want to solve it as if it was an equation to get the critical values. Now this is a quadratic, so solve it however you want. Quadratic formula, completing the square, factoring. I always try factoring first because it's the easiest, and in this case it is factorable. X minus 6, x plus 4. So using the zero product property, we get x minus 6 equals 0, x plus 4 equals 0. So you get x equals 6 and x equals negative 4. So they're not your answers, but they're your critical values. So the idea for nonlinear inequalities is to plot your critical values on a number line. Whether or not they're open or closed will depend on the original inequality. See how the original inequality is or equals to, it has that line underneath it. So you go ahead and close it up. And by doing this, you create 3 regions on the number line: the left region, the middle region, and the right region. What we're going to do is pick one number from each region. Say, I don't know, x equals negative 5, x equals 0 is always a popular one, and x equals 7. And what we're going to do is test these numbers into the original inequality. You can either test it in the original inequality or in the factored form. It really doesn't matter which one you plug it into. I like the factored form, so let's go ahead and do that. So what I want to do is test x equals negative 5. So I'm going to plug a negative 5 in for all the x's. Now the idea is I don't really care what the answer is. I just care if it's positive or negative. So for the first bit here, negative 5 minus 6, I know he's going to be negative, specifically negative 11, but I don't really care about the number. It's going to be negative. And then the second bit here, negative 5 plus 4, I know it's going to be a negative as well. And then a negative times a negative is a positive. So I'm going to put a positive in the left region there because that's the number I tested, the left region. I hope you guys get the idea. What we're going to do is just repeat the process with the other yellow numbers that we selected. So I'm going to, for this explanation, I'm just going to fast forward and write down the final answer. But all I'm doing is I'm plugging into the original inequality, either the factored form or the original, it doesn't matter. And all I'm seeing is if my answer is positive or negative. So if you were to test x equals 0, you're going to get a negative answer. So we're going to put a negative here. If we were to test x equals 7, you're going to get a positive answer. So I'm going to put a positive answer here. Next, you look at the original inequality here. See how it says less than or equal to 0? We have to know that less than or equal to 0 means negative numbers. So my answer, if you take a look at our sign diagram, our answer would be the negative regions. Look at the symbols here, the negative regions. So we only have one negative region, which is the middle. So guess what? There's our answer. That interval is our solution set. All we have to do is write it in interval notation. So we can clearly see that this interval starts at negative 4 and stops at 6. They're both closed, so they're both square brackets. There you go. That's our solution set. Number 22 is asking you to write an equation of a line. The idea is that whether it be in this class, your future math classes, your past math classes, high-level calculus, doesn't really matter. When it comes to writing linear equations, you always need the same piece of information: a slope and a point. If you read the question, it says write an equation of a line that goes through this point here, so they give us a point. But they don't explicitly give you a slope. Now, if you read the whole story or read the whole problem, it never says your slope is this. So that means you actually have to go and find it. You have to do extra work to find it. So the only information they say is it's parallel to the line through these 2 points here. So the thing that this question is testing you on is your knowledge of parallel lines. We need to remember that parallel implies same slope. So since we're on the hunt for slope and they give us 2 points, we should remember the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And it doesn't really matter which one you designate as 0.1 or 0.2. Let's just go in order. Let's call this x sub 1 y1, x sub 2 y2, and then just plug everything into the formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that gives us a negative 2 over negative 2, which is a positive 1. Now, all this work that we've done is to find their slope, because that's just not necessarily ours yet. So all this work tells me that their slope is 1. The problem says we want parallel, which means same slope. So clearly, our slope will also be 1. So now we've done it. We have a slope, good. We have a point, good. Now we can write the equation of the line. You can use y equals mx plus b. I like point slope form, y2 minus, y minus y sub 1 and all that fun stuff. So for this solution, I'm going to show point slope form, but you use whatever favorite form you want. We should get the same answer in the end. So I'm going to use y minus y sub 1 equals m times x minus x sub 1. So again, the thing we have to be careful of is we only use this information to get the slope. Now that we have the slope, I don't care about these points anymore. These are not our points. This is our point, so make sure you use that point there. So we have y minus my y1 is 3 equals my m is 1 times x minus my x sub 1 is 8. So y minus 3 equals anything times 1 is itself, so that's sort of redundant. And then go ahead and solve for y. Add 3 to both sides. You get y equals x minus 5. Right. Number 23 was solving a rational equation. And the idea was to solve a rational equation. One technique is to clear the fraction, multiply everything by the LCD. So I hope we can see that the LCD, we don't have to do anything fancy. It's just all three denominators together because they have absolutely nothing in common. And everything's factored, right? They're all linear factors. There's nothing to potentially be in common. So what I'm going to do is I'm going to rewrite the problem, but give myself some extra room because I know I'm going to have to multiply. Equals, so all I'm doing is rewriting it with lots of gaps. And then I'm going to multiply every single term on the top by the LCD. So this guy gets a 10 x minus 1 x plus 2. The middle gets a 10 x minus 1 x plus 2. The right guy gets a 10 x minus 1 x plus 2. The idea being that all of the denominators should cancel out. So on the left, the x minus 1 cancels. In the middle, the x plus 2 cancels. And in the right, the 10s cancel. And then all I got to do is multiply what's left over. So on the very left, we have 1 times x plus 2, which is just x plus 2. In the middle, we have a plus 1 times 10 times x minus 1, so let's just go ahead and, actually, correction, sorry. On the left, we have this 10 times x plus 2, which is 10x plus 20. And in the middle, we have a 10x minus 10 equals, and then on the right here, we have 7 times, and then just go ahead and FOIL this guy out. So that gives you x squared plus x minus 2. So let's combine like terms on the left here, so that's 20x plus 10s. Equals, and distributing the 7 here, 7x squared plus 7x minus 14. This is a quadratic equation, so to solve a quadratic, you bring everything onto one side. So let's go ahead and just bring everything to the right because the x squared is on the right. So we're going to subtract the 20x's and subtract the 10s here. And we get 0 equals 7x squares minus 13x's minus 24. And then you just solve it however you want. Factoring, quadratic formula, completing the square. I'm hoping, this would be ugly if it wasn't, I'm hoping this guy's factorable. 24, 2 and 12, 3 and 8, 4 and 6. Let's see, 21 and 8. So this would be a minus 3 here and a plus 8 there. Right. Yeah. So then apply the zero product property. Each of these guys gets set equal to 0. And then we can solve it easily. X equals negative 8/7 and x equals 3. Those are your two answers. Now, when it comes to rational equations, you have to check your answers, but you only need to check against the denominators. So if you look at the original problem, denominators, we only had two denominators that had x's, x minus 1 and x plus 2. Any answer that, when we plug into the denominator, changes into 0, we have to throw away. But both of these answers are good. If you plug in either one of these numbers into any denominator, you do not get 0, which means we keep it. They're both good answers. Number 24, write an equation of a line, and they give us intercepts. Now remember, when it comes to writing linear equations, we need two things. We need a slope. We need a point. Right. Now, when they give you intercepts, those are actually points. So we're actually good here. As a matter of fact, they give us the y-intercept, so that's even better. All I need is a slope. Well, how do I find a slope when I have intercepts? You have to remember, x-intercepts is always y at the 0, and a y-intercept is always 0 on the x. So there you go. Just find the slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So in this case here, it doesn't matter which one you call 1 and 2. Let's call this x1, y1, x2, y2. So this is 8 minus 0 over 0 minus a negative 10. So this is 8 over 10, which is 4/5. Now, I don't have to do point slope form or any of that complicated business, because guess what? We have our slope now. And although it's nice to have a point, we have a special point. We have the y-intercept. So just go straight to y equals mx plus b. Because remember, this is the slope here, m, and this is the y-intercept, b. So there's our answer, y equals 4/5 x plus 8. So hopefully that was a piece of cake. Number 25, writing a linear equation. So recall that to write a linear equation, we need two pieces of information, a slope and a point. Reading the problem, they give me plenty of points. So this guy's good. We have good points here. They don't flat out tell us a slope. They don't say that your slope is this. So that means we have to go find it. Well, you have 2 points. You want a slope. Hopefully that makes you think of the slope formula. It doesn't really matter which point you call 1 and 2. So I don't know, let's call this x1, y1. Let's call this x2, y2. And then just plug everything in. So y sub 2 is a 6, minus y sub 1 is a 4, over x sub 2 is a 1, minus x sub 1 is a 2. You do math, that gives you a 2 over negative 1, which is a negative 2. Now at this point, it doesn't matter if you use point slope form or y equals mx plus b, you should get the same answer in the end. I like point slope form, that's what I showed in class, so that's what I'll go ahead and use. Here we have multiple points. Really doesn't matter which one we use. Let's just go ahead and use the first one because, hey, it's first. So we have y minus y sub 1 is a 4 equals the m that we just found out was negative 2, x minus 2. So y minus 4 equals, let's distribute here, that's negative 2x plus 4. And then adding 4 over, you get y equals negative 2x plus 8. Number 26. And again, in class, I did, hopefully everyone heard me say that this should have been a comma. So evaluate I to the 1003rd power. The idea is that when it comes to powers of I, there's only 4 you need to memorize. I to the 0 is 1, I to the first is I, which are sort of self-explanatory, so there really is only 2 you need to memorize. I squared is negative 1, and I cubed is negative I, because the powers of I are cyclical. So I to the 4th is the same thing as 1. I to the 5th is the same thing as I to the 1st. I to the 6th, I to the 7th, I to the 8th, I to the 9th, I to the 10th, I to the 11th, so on and so forth. But if I want to evaluate I to the 1003, I don't want to continue this list forever to 1003. So the idea is that powers of I repeat every group of 4. So I want to pull out the duplicates or the groups of 4 from this big exponent. Pulling out groups, pulling out duplicates, that's a division problem. So if you go old school and divide by 4, so that gives you a 2, 8, subtract, that's 2, 0, so that's a 5, that's 20, subtract 0, 3, and I can't go into 3, so it's a remainder of 3, right? All this work tells us there are 25 groups of duplicates that we can throw away. It's the remainder that we want. So all this work says I to the 1003 is the same thing as I cubed, which this is your responsibility. You need to know that I cubed is negative I. Number 27, write a linear equation. just to refresh our memories, to write a linear equation, we only need two things. We need a slope, and we need a y-intercept, or excuse me, any points. It would be great if we had a y-intercept, but they're not always going to give you a y-intercept, so any random point will do. Right. So if you read the problem, it says write an equation of a line that goes through this point, so yay, they do give us a point. But if you read the whole thing, it doesn't flat out say, hey, your slope is this. All it tells you is it's perpendicular to this line. So what this question is testing you on is, do you remember perpendicular? What perpendicular means when it comes to slope? Why am I thinking of slope? Well, because that's what we need. Well, we have to remember that perpendicular means opposite and reciprocal slopes. So I need to take the opposite reciprocal of that slope. Well, that line is in general form, and I can't read what the slope is in general form. So the thing with this problem is you had to solve this equation for y first. Hopefully it should be a piece of cake. I gotta subtract the 7 and subtract the 5x over, so just move everything except for the y over. So that you gotta subtract the 5x, subtract the 7, and then divide everything by 6. Right. Yes, this looks like a funky equation, but again, the only thing I care about is his slope. So hopefully now it's in slope-intercept form, it's very easy to read, right? Their slope is negative 5, 6. We want perpendicular. So the idea is that you need to know perpendicular means opposite and reciprocal. So our slope will be the opposite of a negative, which is a positive, and the reciprocal, which is 6 over 5. There we go, right? We have a slope now, and we have our point. The common mistake students make is they want to use this line some more. Well, we're done with him. All we cared about was being perpendicular to it, which means we wanted to extract the right slope. We have the right slope now, so I don't care about him anymore. So use this point, use the slope that we found to write the equation. You can use slope-intercept form, y equals mx plus b. What I showed in class was point-slope form, y minus y sub 1 equals m times x minus x sub 1. Use whatever form you want, but your final answer should be the same. So we have y minus, our y value is negative 3, equals the slope of 6/5 that we found out, x minus, our x value is negative 2. Take care of the double negatives, and then distribute. So that's y plus 3 equals 6/5 x plus, if you're not good at fractions by now, just use your calculator. 6/5 times 2 is 12/5, and then all you got to do is subtract 3 over. So your final answer should be y equals 6/5 x minus 3/5. That should be your equation. Number 28 was our mixture problem, our concentration problem. So we just have to remember that concentration is equal to the amount of stuff that you're focusing on. It's the concentration of acid, so it's the amount of acid. It's the concentration of orange juice, so it's the amount of orange juice. It's the whatever the concentration is focusing on, it's the amount of that stuff on top divided by the total volume. Right. So the general idea is to start with the concentration they give me, set it equal to the final concentration you want, and change the fraction depending on the story. So for reading, it says the radiator in the car is filled with a solution of 80% antifreeze and 20% water. A manufacturer of the antifreeze suggests that for summer driving, optimal cooling of the engine is obtained with only 50% antifreeze. If the capacity of the radiator is 3.2 liters, how much coolant should be drained and replaced with water to reduce the antifreeze concentration to the recommended level? So notice that the concentration is focusing on antifreeze. So when I set up my fraction, the amount of antifreeze should be on top. Well, what's my initial concentration? Well, it says it's 80% antifreeze, okay? And how many am I working with? I'm working with 3.2 liters. So that's my total volume, 3.2 liters. Now on top, I'm going to put the amount of antifreeze. Well, if 80% of the total volume is antifreeze, the amount of antifreeze should be, well, 80%, which is 0.8, of the total volume. Now, what are we going to be doing to this concentration here? Well, it says we're going to drain, because what it says here, how much coolant should be drained? So we're going to be draining this coolant. Obviously, if you're going to drain some, I'm going to be reducing the total volume. Now, this is what we have to think about. If you drain this coolant, are you losing total amounts of antifreeze? And hopefully the answer is an obvious yes. Duh. If you drain some stuff, you lose the stuff that's inside of the mixture. But here's the idea. This X here is the amount that we drain. Every single drop of that coolant is not antifreeze. Only 80% of it. So whatever we drain, we only lose 80% in antifreeze. Well, what next happens is it says we're going to be replacing it with water. Whatever we drain, we replace. So obviously, I'm going to increase the total volume again. Now, when I add water, then this whole concentration is focusing on the amount of antifreeze. When you add pure water, you are not changing the amount of antifreeze. So nothing goes on top here. It stays as this. And then I want it to equal the final concentration. Well, the final concentration that they want is 50%. That is the equation that we're solving. Of course, the x's and the denominators cancel out, so 0.8 times 3.2 minus 0.8x over 3.2 equals 0.5. That is really the equation that you're solving. So just go ahead and do math. So the first thing we're going to do is multiply both sides by 3.2 to get rid of the fraction. And at the same time, let's take 0.8 times 3.2. So this guy here is 2.56 minus 0.8x equals, and I'm going to multiply the 3.2 over. So 3.2 times 0.5 is 1.6. Go ahead and subtract the 2.56 over, so that gives you negative 0.8x equals 1.6 minus 2.56 is negative 0.96, and then divide both sides by negative 0.8 gives you a positive 1.2 liters. So the answer should have been 1.2 liters, or B. Number 29 is an absolute value inequality problem. And again, when it comes to setting these up, you just have to know how to set it up. Now, why stuff is greater than some numbers, let's say C. Why is the setup the way it's going to be? Well, I've already explained it in class. If you forgot and you really want to know, talk to me outside of class and I'll be gladly to re-explain it to you. But the idea is this. Every single absolute value that is greater than a number problem is set up as follows. You write the problem as is, nothing changes, just drop the bars. Or, you have to put the or there. That stuff on the inside, flip the inequality and flip the sign. That's it. And then you just solve the problem. So in this particular problem, if I have absolute value of x plus 9 is greater than or equal to 6, the setup is just rewrite the problem as is without the bars, or the problem, flip the sign, flip the number. And then you just go ahead and solve it as normal. I hope it's very obvious to everyone that both problems require the same single step, subtracting 9 from both sides. So we get x is greater than or equal to negative 3, or x is less than or equal to negative 15. I actually like to write the problem with the smaller number first, with the less than first. So I'm going to write this guy first here. So x is less than or equal to negative 15, or x is greater than or equal to negative 3. The reason why I'm going to do this is because the problem said interval notation. So to visualize interval notation, just go ahead and plot your two answers on the number line. So negative 15 here, negative 3 here. They're both going to be closed because the inequalities had an or equals to. Now x is less than negative 15. Well, numbers get less than to the left. Or x is greater than negative 3. Numbers get greater to the right. Interval notation describes these shadings here, so hopefully everyone can see that this left shading will go on forever to the left, which is negative infinity, comma, negative infinity, and then it's going to stop at negative 15. Infinities are always open, that 15 is closed. I do have my other interval, the right interval, so I need a union. This right interval starts at -3 and it's closed, comma, and hopefully we can see that the shading will go on forever to the right. So forever to the right is positive infinity. That should be the solution set to this inequality, which is choice D. Here. Number 30, multiplying rational equations. Now remember, when it comes to simplifying, multiplying, or dividing rational expressions, I actually don't want to do any of that stuff. All of this should mean the same thing. Factor and cancel. So if you had a hard time with this problem because the problems were getting really, really big, it's probably because you forgot. When it comes to rational expressions, almost always involves factoring and canceling. So let's factor every piece of this problem. So that means I'm going to factor the first numerator, the first denominator, the second numerator, the second denominator. So factoring the first numerator, that hopefully should be a brief exercise, x minus 5, x plus 4. Factoring the first denominator, I can only do GCFs. The only thing I can do is pull out an x, that's x plus 4, times the second numerator, I can pull out an x squared, x plus 2, and the second denominator factorizes into x minus 5, x plus 2, right? So this is the first denominator. Well, I'm not going to highlight it. You guys can tell. So then all you got to do is just cancel. Whatever's on top and bottom, cancel it out. So I have an x plus 4 in common. X minus 5 is in common. X plus 2 is in common. What I'm left with is an x squared on top and an x on the bottom. I can actually cancel out one of those x's because what's left over is x squared over x. You can cancel out one of those x's and give you a regular simple x. Last but not least, a nonlinear inequality. So the idea is that you want to get 0 on one side, which already is. And then what you want to do once you have 0 on one side is to think or pretend that the problem is an equation. It's not an equation, it's an inequality, but you're going to pretend that it's an equation. Well, since it's already factored for you, it's actually pretty nice. It made things easy. Just go ahead and apply the zero product property, giving you x equals 5 and x equals -3. What you do with these answers is you plumb on a number line. We're going to build a sign diagram. So -3 and 5. Whether or not these are open or closed depends on the original inequality. Because the inequality is greater than or equals to, it has a little line underneath it, it will be closed. And I hope that you guys can see that these two critical values split the number line up into 3 intervals. The left interval, the middle interval, and the right interval. What you want to do is just pick a number from each interval. It doesn't really matter what number. Say x equals -4 here, x equals 0 is always popular, and say x equals 6. And what you're going to do is you're going to test these numbers into the original inequality. I always like to plug it into the inequality that has that it's in factored form. Since it's already in factored form, that's sort of nice. So wherever I see an x, I'm going to plug in a -4. So that's -4 minus 5, -4 plus 3. I actually don't care what the answer is. I just care about if it's positive or negative. So -4 minus 5 is definitely negative. -4 plus 3 is definitely negative. Negative times a negative is a positive. Because I tested the -4 region and it got a positive answer, I'm going to put a plus sign up here. And basically what you're going to do is you're going to repeat the process testing the other yellow numbers. Test x equals 0 and x equals 6. So I hope you guys get the idea. I'm just going to fast forward through it, just write down the result. But basically you would do the same thing. Just plug in the numbers into the problem and see if you get a positive or negative answer. So if you were to test x equals 0, you're going to get a negative answer. And if you were to test x equals 6, you're going to get a positive answer. Now, what you need to do is, again, look at your original inequality. See how it says greater than or equal to 0? We need to know that greater than 0 says positive. Those are positive numbers. All positive numbers are greater than 0. So what you have to do is look at your pluses and minuses that you put up here. That tells you that your final answer is the positive regions. And so I'm going to shade the positive regions here. This region and this region. All right. So all you need to do is write it in interval notation. Hopefully the region, you can see that the region to the left will go on forever to the left. So forever to the left is negative infinity, and it stops at -3. Infinities are always open, that -3 is closed. I have another interval to the right, so I need to join them with a union. That rightward interval starts at 5 and goes forever to the right to infinity. That is the solution set to number 31.